So in this problem, we're given the coordinates of the vertices of a triangle. We are only provided with the two vertices of the triangle, but we are also provided with the coordinate of the centroid of the same triangle. Then we need to obtain the coordinates of the third vertex as well as the area of the triangle. So let us begin. Let's suppose that we have a triangle A, B, C. Here, the coordinates of A, let it be 1, 4. Coordinates of B, we're going to consider it to be a 7, 2, and the coordinates of the third vertex C, since we don't know it, we are going to consider it as x, y. It's also given here that the coordinate of the centroid is 5, 3. The centroid is the point where the medians of the triangle meet. Now, there is a formula for finding out the centroid of a triangle. Let's specify that particular formula. Let's say we have a triangle having vertices x1, y1, x2, y2, and x3, y3. Then the coordinate of the centroid is given by the expression where we take the x coordinates of each of the vertices, add them up, and divide by 3 to get the x coordinate of the centroid. And to find out the y coordinate, we take the sum of the y coordinates of each of the vertices and then divide it by 3. Okay, so using this particular formula, then the coordinate of the centroid, let's call it g. So that's going to be given by, so here we're going to add the x coordinates of the vertices. So we have 1 added to 7 plus x divided by 3. That's the x coordinate, and the y coordinate will be 4 plus 2 plus y divided by 3. Which means that this comes out to be x plus 8 divided by 3. And we have y plus 6 divided by 3. But in our problem, it's already given here that the centroid has the value 5, 3. That means we can now equate x plus 8 over 3, that's the x coordinate, with the value 5. And then we can also equate y plus 6 with the value 3 over 3 equal to 3. So let's solve for the values of x and y. So x comes out to be equals to, so we have x plus 8 equals to 15. So x will be equals to 15 minus 8, that's 7. Then we have y plus 6 equals to 9. So y will be equals to 3. So that means the value of the third coordinate, that's going to be 7, 3. So now we have the information regarding the third coordinate, or we can say that we have the coordinates of all the three vertices of the triangle. So our next task will be to obtain the area of the triangle. So let's do that. So if we have a triangle having the vertices x1, y1, x2, y2, and x3, y3, then its area is given by the formula half times the absolute value of x1 multiplied to y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. So let's begin by supposing that A corresponds to x1, y1, B corresponds to x2, y2, and C corresponds to x3, y3. Such that the area comes out to be equals to half times the absolute value. What is x1 here? So that's 1. 1 will be multiplied to y2. So y2 is 2 minus y3. So y3 is 3. 2 minus 3. Added to x2. So here x2 corresponds to 7. So we have 7 multiplied to y3 minus y1. So that's 3 minus 4. Added to x3. So here x3 corresponds to 7. 7 multiplied to y1 minus y2. So we have 4 minus 2. Right. So this will be equals to 1/2 multiplied to absolute value 1 times 2 minus 3. So that's negative 1. Then we have 7 times 3 minus 4. So that's going to be negative 7. And then we have 7 multiplied to 2. So that's going to be 14. Fine. So let's find out this value. So here we have 14 minus 7. That's going to be 7. And 7 minus 1. That's 6. So we have absolute value of 6 over 2. That comes out to be 3 square units. So this is going to be the area of the triangle.